Hello, everyone. I think there might be some delay as well, so we will give it a couple minutes before we get started, maybe 1 or 2 minutes, and then we will start. And for anyone that's joining, there's a QR code at the top right over here for a poll. If everyone can just fill out the poll, it's just a quick questionnaire about what your role is, and that can help us with the rest of the presentation to be able to kind of tailor it a little bit more. All right, well, let's just give it 1 more minute and then we can get started. All right, so let's get started. Hopefully everyone has joined by now. Again, sorry for I think there's about 30 seconds delay. Let's go quickly over the agenda for this webinar, starting with kind of an overview of what is exactly the problem that we're trying to solve here. What is a self-healing workflow, and how do you kind of put that inside an agent so that the agent can create a loop around that? And the two main aspects that we're going to cover in this presentation is going to be the context as well as the workflow. So in terms of the context, we really want to see what context you already have, how can you unify that context in a single place, and then enrich that with more information. On the workflow side, we're going to take a look at how you can start basically utilizing a self-healing agent locally within the local environment, and then it can allow that agent to run things in the development environment, and then how you can go into production with that. All right, so taking a look at kind of the problem here is that most data engineers and analytics engineers are basically spending a lot of time every day, every week on data failures. So there was a survey that done around 2-3 years ago that showed that 40% of the workday is spent on quality issues. So that's everything from data quality checks that failed or reported by the different team members. And a lot of these failures actually take over 4 hours to actually be able to detect them. And that means that downstream, someone actually made a decision on that wrong data, or basically it's creating issues for the business people. And this is taking a lot of time away from data engineers, analytics engineers, and not really allowing them to do the work that they want to do. And I've been there. For anyone that's been there, you know that you have more important priorities going on, and then someone reports an issue, and you spend most of your day essentially fixing that problem. And 74% of within the survey, 74% of people said that they actually heard the data problems from someone else. So as we can see, there's a few different problems here. One is that there's a lot of time spent on this, and a lot of that is actually the investigation that goes into it. It is the troubleshooting, finding what the issue is, what the impact of that issue is, and then being able to actually create the fix for it, test that fix, and deploy it in production. So now let's take a look at what exactly is the workflow. So let's think of like a more of a data engineer or an analytics engineer's personal workflow. The first thing is that you get detected. So you detect the problem, whether you were alerted by a failure, like let's say an airflow pipeline failure or a data quality check that failed, and you're alerted. And hopefully not at 3 a.m., but you get alerted by that issue, and then you have to go and diagnose the problem. So you most likely look at the lineage. You see, okay, this is where the problem happened. You go upstream. You kind of identify where the root cause was. If it's a SQL model, then you're going through the CTEs. You're finding exactly where that issue happened, and then from there, you're going to start thinking about what kind of fixes can you push. So there are short-term fixes, long-term fixes. You can, for example, do a quick rerun just to unblock things, and then you maybe want to create a PR to actually fix the root cause. Or that kind of step is kind of triaging the issue, understanding what action that you have to take, and then delegating that within yourself, within the team, or figuring out how to do it. And when it comes to the actual fix, a lot of times you have to essentially most likely test it in a development environment. You start locally, and then you test it in a shadow development environment. And then you want to actually maybe even test if it's a logic change that you made. You want to test that with real data. So most likely you either copy some data from production over, or you run it in production, but with a different schema just to see what the downstream looks like. And lastly, you want to verify, you want to make sure that the problem was solved. And the final step is learning. So normally how the learning right now happens is that an individual is really learning from that specific incident that happened. And that information, that context normally stays within your mind, and it's not really shared somewhere unless maybe you have a frequently failed kind of pipelines part of your documentation, or an incident report or something like that. Now, basically what a self-healing pipeline does is first creating this workflow agentically. Some parts of it might not necessarily need an agent, but it's just more about building the context and stuff, and then adding agents to take care of some of these tasks. And most importantly, creating a loop around this so that your agent is able to write back the learnings into your project. And next time something that happens, it either proactively prevents it, or it's able to actually respond to it in a smart way. Now let's take a look at basically how a self-healing pipeline would work and what are the specific things that you need. So the first thing that we want to take a look at is the context. I'm sure everyone who has worked with anything AI knows that the context is the most important thing. And basically, the context starts with what you already have, what you need to enrich and complete, and how do you bring all of that context together. When it comes to the tools, so this can be everything from MCPs, APIs, skills that you write for your agent, and basically different things that you give the agent that it can not just access the context, but also take actions on your behalf. And lastly, it's the guardrail. So this is mainly for when you're actually creating the loop, when you're creating the agent and allowing the agent to run in production. And this is the rules that you want the agent to follow, the instructions, the specific format, how it communicates with you and your team, and basically kind of the job responsibilities basically of the agent. Now let's take a look at a really interesting example. So in this example over here, you basically, if you right now go and connect Claude or Codex or Cursor kind of thing to your data, you might get a response like this. So in this example here, I asked the agent, how did this specific Google ad campaign perform? And it said it didn't perform that well. Do not scale it. It even recommended something to me. But when you look under the hood, actually, the data was just not there. So it was missing 2 days of data. And this agent incorrectly and very confidently responded and said, hey, this campaign is not good, just scratch it out. But when you actually look at the data, the underlying data, there was data missing and it didn't have the context because this agent in this example only had access to the report layer. So it only had access to the tables in the final kind of gold layer of the data warehouse. And then in the second image to the right, I basically gave the agent like full access to the pipeline. So everything from the ingestion layer, all the transformations that happen before the gold layer, and all the code, all the metadata, and also logs of the pipeline runs. So this time when I asked it investigate the raw data and validate the performance again, it went and looked, and if I looked at the logs of this agent, it went and it started from the top of the lineage. So it looked at the data ingestion. It saw that actually looking at the logs, you see that the pipeline ran successfully. So the ingestion was technically successful. But when you look at the number of rows that were ingested for those 2 days, it's completely zero. So we were missing 2 days of data. It was like not even zero, it was like very little or something. So it was the fact that the API just didn't provide the data to us. And then downstream, everything ran successfully. There were no quality checks that caught this. And someone asked a question and asked the agent to analyze the data and got the wrong result. And imagine if this was in a real production environment, you would have people complaining and they're not really happy with kind of being given wrong answers, and it creates distrust with the data and the agents. So a lot of what we are talking about today and a lot of like the main reasons why you want to create a self-healing pipeline is to essentially have reliable pipelines that process data correctly and output data that is of high quality and can be trusted. Because once you lose the trust with the people actually consuming the data, they're never going to trust anything agentic. They're not going to trust even the normal pipelines running. So this is a point that I really want to emphasize here. Now let's take a look at, for each of the different problems, how are we going to solve them? So we're going to dive deeper into each one a little bit more, but just on a high level, you have a lot of context already in your pipelines, but it's incomplete. It's messy, it's all over the place, and you are probably not maintaining it. So the first step is to go and complete the data as much as possible. I mean, the context as much as possible. And it's better to start from somewhere than nowhere. So if you're hesitant about getting an agent to actually fill in the blanks for you, this is a time for you to actually go in and ask the agent, whatever you know about me, about my business, put everything inside a document, put in the repo, go through every single pipeline, go through every single asset and model, and just add as much context as possible. Once you do this, at least you have something to work with. And that way, when you're like testing things locally and the agent gives you the wrong answer, you say, hey, no, that's not the correct table, that you shouldn't be looking at that, or that pipeline is not actually supposed to do that, blah, blah, blah. And the agent goes and updates the documentation and the context according to that. The second problem is that probably the context is very siloed. So we're going to dive a little bit deeper into here as well, but the main thing is that you want to unify this, whether it's by giving the agent access to different tools that you're using or by having a single source of truth for all of your context. And the last thing, and probably the most important thing, honestly, is a feedback loop. So you need a feedback loop that the agent self-learns, but also learns from you, your team, the business people in your company, and the data consumers, and it constantly is able to update itself and the context. All right, so let's take a look at what probably most people's stack looks like if they're using a modern data stack. And this is where all three of those problems kind of actually come about, is you have different specialized tools for different parts of your pipeline. You have a tool for ingestion, you have your data warehouse, you have a transformation layer or an orchestration, and then you have your BI tools and maybe some documentation like Confluence and Notion and things like that. There's a lot of context already existing here. The agent is able to just read the code itself, look at the schema, metadata, go through the lineage, understand the dependencies, and if it has access to your docs, it can learn a lot from there as well. But the key thing here is that you need someone to go into every single area and maintain the documentation and the context that exists there, and also unify them together somehow. So that's where the unification problem becomes very important, and it becomes a project by itself. So if we take a look at, for example, so anyways, we will come back to the how to unify it, but now let's talk about first the first part of the problem, which was the incomplete context. So your pipelines already have a lot of information and a lot of context, but you want to complete that. So what I'm going to go through now are a few different examples of how you can do that. So starting at the repo level, you start off with an agents.md file. A few things to keep in mind when it comes to data context, and especially for the self-healing agents here, is that you want this file to contain kind of generic information about your repo, how to navigate the repo, and kind of general concepts and knowledge about your company, rather than more specific things. So you don't want to give it the safeguards and kind of like what's called rules and instructions in here, because this agents.md file might conflict with a system prompt that you later set up for the agent that actually does the self-healing for you. So you want to keep this as generic as possible, that different agents for different purposes can use this. So you might have a self-healing agent, you might have an AI data analyst agent, you might have an analytics engineering agent, and you want each of these ones to read this without getting confused or creating conflicting rules and instructions. Now moving on to kind of, again, company level or organization level, is you want some glossary or semantic layers. So in here, you define key metrics, the lingo that goes on within your company, the acronyms, the jargon that normally agents cannot understand. They can infer it from your pipeline or from the descriptions of things, but they can't really rely on it that easily. So it's better to just jot that down inside a single file. And again, this is going to be hard to set up initially, but it's better to start off from somewhere and just iterate on it as you kind of like make changes to your repo and as the metrics and definitions change. Now, kind of moving into the pipeline level, there's a lot of information that already exists. So your pipeline configurations, the connections, the schedule, any alerting kind of channels that are connected to it, all of these things. As well as what I would suggest to enrich here is add some tags and metadata at the pipeline level. But even more important than that, I think, is a pipeline level README. So in here, just put out the intent of the pipeline. What is the purpose of this pipeline? And whether in here or in the pipeline, like configuration file, you want to add some tags and owners in terms of like, for example, if you're tracking monitoring costs, you can have a cost center here. You can have basically the domains, the owners of this pipeline. And a lot of that information helps with the agent to know how to triage things, who to contact when something goes wrong. And a lot of this context becomes very important during the diagnosis level and the triage level of the workflow. Now we're going to the table level of things, and this is where it helps with detecting the problem, but also identifying the solution and how to test things and stuff. So at your table level, you will have the description, you will have kind of like, high level information, and then there's metadata about the table. So some of the metadata will sit inside the model or the asset that you have, and some of it will live inside the data warehouse. So the ones that live and should be living inside your pipelines themselves in the asset or model file is things like the tags, the owners of this table, basically the SLA, for example. So if this table breaks at 9 a.m. UTC and the SLA is 6 a.m. UTC that this needs to be delivered, that automatically triggers the agent to understand that, hey, this is very important, and it's been 3 hours delayed, and people are maybe making decisions based on the results of this table. So it's able to basically triage it better and alert you better about it as well. And another thing to keep in mind when it comes to the table level metadata is that a lot of this information might also live inside of your data warehouse as well. So Some of it might be duplicate, so you have to be careful to not have any conflicting metadata and context. But also, you will want to have um, basically, some information like when was this table last updated, when was this table created, things like that, as well as also the query logs too. So you will have information like who is querying this table, who are the basically users that are querying this table, what are the queries running against this table. So a lot of that context also will live outside of your pipeline as well. Now, kind of moving on to column level metadata, and this is where you're getting more granular, and it becomes not just like figuring out what the problem of that failure is, but it helps the agent understand how to fix things as well. So, for example, you can have checks. If you have custom checks and quality checks at the pipeline level, it helps the agent kind of proactively understand what is the logic that's going inside this specific column. And also, the column level information helps with column level lineage as well. So if there's a column that was, let's say, has been showing up null upstream, the agent is able to track the lineage downstream and see who are the different people, the different teams, and pipelines that are going to be impacted by this issue. So column level information is very, very important for both diagnosis and also pushing fixes as well. Now let's get into kind of more advanced, let's say, or more kind of like what can really help make things more sophisticated for the agents. So you have custom checks as well as unit tests. These two are very important concepts to keep in mind when developing your models. So custom checks are basically a SQL check that run after your model or the asset was updated. So in this case, for example, this asset runs, it updates the table, and then this SQL query runs. And if it fails, then we're alerted about it. So this usually helps with the result of the query, and if the result of the query doesn't pass the smell test kind of thing. And this is kind of like a built-in guardrail for agents when they make changes. So when they make some changes to your query, and they run it in development environment and test it. If this breaks, then they understand, hey, the change I made doesn't pass this test. And depending on the other guardrails that you've set up, you might say never change custom checks, never change any tests or checks. If you reach that point, either try something else or come and alert us. So this is a really good way of kind of building in processes that basically prevent your agent from making changes that can break the logic of your queries. And another great example is unit tests. So this will basically pass some predetermined data into the query of this asset and check against the expected results. This is another great way of testing the specific logic of your query. And if the agent makes a change and it breaks this, then it's a great way for you to understand, okay, this agent is making a change that is breaking the logic and it's violating basically what this table wants to do and the purpose of this table, and it can stop right there, or it can alert you, or whatever kind of process that you set up there. So just to recap, I think the custom checks and unit tests are a great way for the agent to be able to understand the logic of your queries, as well as it's a safeguard, it's a guardrail in place to prevent the agent from making changes that are going to break things in a very fundamental way. And lastly, the lineage and materialization. So this kind of goes without saying, but it's very important for the investigation part of the workflow for the agent to understand where the data is coming from, what's the table level, column level lineage, and then also assessing the impact. So this combined with, for example, tags becomes very important. So if you have, let's say, downstream assets from a failed asset, that has a tag that's, let's say, mission critical with an SLA of 6 a.m., and you have an asset that failed at 3 a.m., and all of the downstream assets are now waiting for this to run, the agent can quickly infer that basically this is a very, very important asset, and the failure here is going to cause mission critical problems. So this is basically how you can kind of build in some context into your pipelines for the agent to understand and assess the severity of the problem and kind of assess the impact as well. All right, so now let's move on to the second problem, which is unifying all of the data, all of the context that you have. There's really two ways to go about this. If you're using different tools and your context sits in between them, once you have figured out mapping them out, and once you have figured out kind of completing them and enriching them and all of that stuff, there's two ways to kind of bring them together. You can either use a kind of out-of-the-box tool that basically connects to these different parts of your data stack and brings all the context into a single context layer. And this has its pros and cons. It's very complicated and usually very expensive. It's more suitable for larger organizations with a lot of different moving parts. And it creates a single source of truth for all of your context, and you just give the agent one access to one single place. On the other hand, you can glue it yourself. So you can build skills and give MCPs and API access to your agent for it to, for example, connect to Fivetran, connect to Airflow, connect to different parts of your pipeline separately, and pull the context every time. Or you can even kind of build your own context layer where you have a process that gets all of that context, puts it into a single place, and then your agent can access it all together. The other option, which is a single platform, a kind of unified platform option, is becoming more and more common. So we see, for example, Fivetran dbt consolidation, other companies consolidating, Databricks kind of trying to have a full end-to-end solution. The reason is because you want to unify the context at a native level. So kind of the AI native platform kind of notion is very important here, because if the context is in the same framework, in the same language, in the same place, it's much easier for the agent to access it and actually utilize it efficiently. And that's kind of what Bruin started off as well, is a single framework from the ingestion, transformation, orchestration, and even the analytics side of things, so that everything sits in the same framework, sometimes even in the same repo, so that the agent just needs a single MCP to access everything. So that's kind of where we're headed towards, but you can also build your own context layer or glue them all together. So as I kind of mentioned, you might have different tools and you want to give them this, basically the skills, which usually tells them how to use the MCPs and APIs to connect to these different tools and build the context layer. All right, now let's move on to the last section. So I guess before we kind of move on there, let me just recap on the context. So the context essentially is the first thing that you need to get right. And the context starts with the context that you already have in your pipelines. The best thing to do right now is to first map that out. What do you have? What do you not have? And what are the inconsistencies? What needs to be completed? What needs to be enriched? And kind of map out those requirements so that you can get started on that. And then the second layer is unifying this all this context together. So as I mentioned, you can either connect to different tools and bring them all together, or give the skills and kind of MCPs for your agents to access these different tools, or you can use a tool that kind of already unifies everything together. And the part about feedback loops and stuff we will come back to in a bit, but that's kind of on the context side, that's the summary of it. All right, so now let's take a look at the workflow. So let's say you have now, let's give a proper kind of scope for this before we move on. So you have a pipeline, or let's say you have a repo with a bunch of pipelines. You have your repo level context, you have your MCP set up, you have all the pipelines configured and all the connections, and most importantly, all the context and everything. You have everything set up and you start locally. So the first thing to do is really just have your repo and start with a simple investigation. So you have a pipeline failure, let's say in Bruin Cloud, and you don't have the agent connected yet to Bruin Cloud. Just start with taking the logs and coming and giving it to your Cloud Code or Codex or Cursor, and just give the logs and say, hey, there was this failure in the cloud, the pipeline failed, and investigate it. And basically, you're putting the context to test here by seeing, okay, what is it accessing? How is it able to navigate the repo properly before it's using any tools and any MCPs, nothing. You just want to test the context locally and make sure that it works. And start with the investigation. And this is probably where most people are at, is like you're doing things locally and you're setting things up and you're asking your agents to basically investigate things and help you with the initial troubleshooting. And then once it's able to basically find the specific root cause, it might suggest a fix. And then that's when you also test the agent's ability to understand the context of your pipeline about how to like actually test the fix. So for example, you say you can explain to the agent, normally what I do is do X, Y, Z, and I run it in Shadow, for example, and then I run it in Shadow with a different schema prefix just to see what the logic actually looks downstream. And basically, you want to get the agent to work through your personal workflow and document all of that back to the repo level, uh, basically the agent's MD and the README files, so that you have a kind of a documented workflow as to how you actually investigate and fix things and test them within your local environment. So in other words, you're basically onboarding and teaching the agent on how to do the things that you're doing right now. And this is what you would do with a new hire when you have a new hire. And let's say there's an incident and they sit down with you and they basically kind of shadow you and they watch you. How are you investigating an issue? How are you testing things in the shadow environment? And how do you go ahead and make the PR and do the reviews and everything? So think of this step as the agent shadowing you and kind of you shadowing the agent while they do a few of these simple tasks. All right, so as I kind of mentioned, you can start with one single failure, go through the entire process from detecting the problem, diagnosing it, fixing it, running things in the different shadow and development environments that you have, and then make sure that the agent is actually writing all this back to a specific document. So as I mentioned earlier, the agent's MD file of your repo shouldn't necessarily be about self-healing, but some of these things can be documented there, or you can ask the agent to put in a separate documentation, a separate document, or even a skill, where inside that skill, you're defining the workflow of a agent, basically, when it comes to self-healing pipelines. So you can call that skill, for example, self-heal skill. I have an example of this as well that you can check out our Slack for. Inside there, you can play around with the specific example as well. But that agent is essentially using a skill called self-heal, where it detects the issue. It's able to kind of go through the workflow that I defined for it and communicate things and triage things as I have instructed the agent to do. All right. So the next step before we go into kind of like, kind of the middle step before you want to actually take things into production is to set up some CI/CD workflows where you kind of this is kind of both like for the agent, but also using some proactive kind of methods to prevent your pipeline from essentially breaking when you know that it's going it's not passing specific tests. So, for example, in these workflows, you can have the agents run the quality checks, run validation, run the unit tests, and you can even have basically an impact assessment where you look across the specific repo or even across multiple repos where you check, see, okay, the changes made to this specific asset or this column, what is the impact downstream? Was everything addressed and updated? And this step is really just to kind of proactively prevent things from happening. And then when you want to actually deploy this to production, I'm not going to get into like how to actually set up the agent. There are different tools for this part. You can, of course, check out different providers that provide basically agents that you can use. But in this example, I'm going to use the Bruin agent that runs in Bruin Cloud and is able to basically do this entire flow. So the first thing that you want to do is configure your agent. You want to give it specific access. So this access will be to your repo, maybe to a communication channel like your Slack or Teams. And you want it to have access to your data warehouse, most likely just read access so that it's able to query the tables, it's able to read the table metadata and stuff, and you don't want it to actually be able to write anything back. And with these three different things, sorry, one more thing, it also needs access to the run logs. So the agent needs to basically access the repo to see the code, to see all the context layer that you've built. It needs to have access to the cloud runs, so the pipelines when they ran, and also you can give the agent access to actually create runs as well. So this is very important when it pushes a fix. Let's say it creates a PR, you approve it, it pushes it, and then now it needs to go and create a backfill. This part is very important if you want the agent to handle. You would need to give it basically access to execute actions in Bruin Cloud or in Airflow or whatever tool that you're using. And lastly, you want the agent to be able to communicate with you. So you want it to actually connect to, for example, Slack or Teams and be able to read any alerts that you're getting there, or if someone tags the agent and says, investigate this, or if you have a scheduled agent that, for example, every morning goes and checks your pipelines, makes sure that everything ran perfectly, then it knows which channel to go into and notify you about what it did overnight. And one more thing about actually the communication side is that if you really set up your context very properly, you're able to actually go and take a look at a specific, not you, but the agent can go take a look at a specific asset and see, for example, this asset failed. And downstream, there's two tables that are marked critical. One is a finance table and one is a marketing table. And the owner of this one is, for example, the channel, the Slack channel marketing team, and the other one is finance team. And it can actually, based on that, infer who to notify in those channels. Or you can even give individual people's names that are owner of that specific table, and it will go inside Slack and notify that specific person. So it really can act as like a normal person would do in these kinds of cases where something breaks. They do an they assess the impact, and they know exactly who to contact and alert as well. So the loop essentially that you want to kind of create, as we mentioned before, is you want to be able to first detect the issue. So this can be actual pipeline failures. They can be quality checks. They can be a scheduled agent that goes and checks your pipelines and understands, like, if there has been any, of course, failures, but also like anomalies or anything like that, and being able to check the logs, the lineage, diagnose, triage, assess the impact and everything, and then go ahead and actually fix the problem, create the PR, depending on the scope that you've given it, and be able to run things in your test development, sorry, in your test environments, and then finally be able to actually learn from everything and maybe do some follow-up PRs where it will go and update the documentation in the pipeline or in the repo with the additional lessons learned, or if any of the context changed, or let's say during that incident, you said, actually, this table, the owner is this person, and based on that information, it's able to go and write everything back. Now, let's kind of actually dive a little bit deeper into that feedback loop. So generally, I would say there's two ways that your agent can learn. Actually, three ways. So the first thing is that the agent has a memory, and that's a great start, generally speaking. And across sessions, agents sometimes are able to share memory and stuff, but it gets very complicated, it gets very blurry. It's really not a reliable way to actually build a context layer. You don't want the agents to kind of just keep things in mind. It's the same thing as you having a single person in your company that knows everything about all the pipelines. At some point, you realize that, hey, like this person is going to leave, or they're going to forget things, so they need to jot things down somewhere. So that kind of brings us to two specific loops that you want to create. One is that the agent gets corrected. So this is kind of like, think of like, you ask an agent to look into investigate an issue, and it starts looking into things, and it, let's say, wrongly identifies the incorrect ingestion assets that ran, and maybe there was a broken lineage or something like that. And or in most cases, like, it's more front end facing. So let's say you ask it an analytical question. You say, hey, what's our revenue for last week? And it answers incorrectly because it defined revenue incorrectly, or the definition of it was conflicting across your repo, or it was just completely missing or something. So in this example, you're actually correcting the agent. So this is kind of the first step here, is that you want to correct your agent all the time. You want to be able to actually communicate with your agent the same way that you do with your coworkers. So within Slack, within your agent session locally or in the cloud or wherever it is, you want to be able to correct your agent, and the agent should know who has the authority to correct it and make updates to that specific part of the context. So an example of this is, for example, if you have set a rule that only specific people are able to update, let's say, business critical tables in the finance department, then if, I don't know, Josh from marketing corrects the agent and says, hey, no, that's not how we define revenue. Actually, we define it like this. Then the agent knows that, hey, I got corrected, but I'm not going to go and correct this in the context layer because this person is actually not authorized to correct this. So this is, again, another reason why you want to have tags and ownership context existing within your pipelines. Now, the other type of correction is kind of more of you can kind of say self-learning of the agent. And this normally happens through silent failures. So if, for example, a pipeline ran successfully, like the example I showed you at the beginning, where the pipeline ran successfully and people looked at the data, they said, oh, the ad campaign actually performed really bad. Let's just cancel the campaign. And in that case, it was a silent failure because nothing actually failed. No one got alerted. And basically everything went all the way until the decision-making point without anyone actually getting alerted or fixing anything. So in those cases, when an agent goes and does the kind of post-mortem investigation, they should self-learn and kind of identify that gap inside the pipeline and push a fix for that. So in this example, it would be a quality check that tests and checks for freshness of the data and makes sure that there is new data actually coming in. So this is kind of one example of, like, how the agent should be able to self-learn and constantly improve your repo in terms of not just the written, like, text context, but also in terms of the code itself. So whether it's adding additional quality checks and unit tests and things that test the logic, so that your pipelines are self-healing in that sense as well. And so as we kind of move towards the end of this kind of like webinar and this workflow, you want to kind of create a loop around this. So one thing is to have, so far everything that we've talked about, it started from you getting triggered or basically alerted that something went wrong. And then most likely you tag an agent and say, hey, investigate this. So to automate this or create a loop around this is two things. One, you can have a scheduled agent, for example, at regular intervals, maybe once, twice, maybe every hour, that goes and checks your pipelines, just checks the logs, sees if anything failed, and does the initial investigation, maybe creates GitHub issues or linear tickets, assigns them, kind of does the initial triaging as well. And that's kind of more of a scheduled batch kind of process, we can say. Another one is having triggers that automatically trigger the agent. So in some cases, for example, like in Bruen, you can have, I mean, it's not a publicly released feature yet, but you can have an agent as an asset that basically comes after a failure. So you write within the logic of the pipeline that if this pipeline fails, then trigger this specific asset with this specific system prompt. And that basically becomes more trigger-based or event-based, where once a failure happens, the agent automatically wakes up and starts the investigation as it happens. And this is perfect for more time sensitive kind of failures that happen. So that's kind of the two different ways that you can create a loop, is just having a schedule where the agent goes and checks things. Of course, you can always trigger it yourself, or you can make it self-triggering by adding events inside your pipeline. So kind of the just to wrap things up, the last thing and probably maybe the most important thing for some people is how far do you want to let the agent go? Like how much like autonomy basically you want to give the agent. And this is where again in the agent's MD file, in the system prompt, or in the skills that you create, you can set out the specific rules and instructions for the agents. Most people are kind of sitting towards where the agent goes and makes the PR for them. The next step would be for you to allow the agent to have access to your development environment, actually test things in the development environment, and then finally let the agent be able to read your production logs, go ahead and actually handle something. So not every failure requires actually a code change. Sometimes, let's say the data was delayed and the ingestions failed because they waited for so long and the retries weren't good enough, and you want an agent to basically just go ahead, wait, let's say 30 minutes, 1 hour, query, maybe like make an API call, sees that the API is back up, and then goes and triggers the ingestion. So that's something that basically, for example, a data engineer would do when they get alerted at 3 a.m. Now you basically want to put that kind of responsibility on an agent that can do it autonomously without actually waking anyone up. And maybe it just sends a message in Slack and says, hey, this ingestion failed again, and I just went ahead, waited for it, reran everything, and everything looks fine now. So kind of based on your appetite for how much you want to give autonomy to an agent, you can just start with letting the agent help with a diagnosis, all the way to actually going and running things in production for you, running backfills, creating PRs, or even merging PRs, depending on your appetite. So just to recap, your context needs to be complete, and you need to enrich that. You need to maintain your context layer through feedback loops. And most importantly, you need to unify your context in a single place. And then once you have everything, start locally, run things, kind of let the agent shadow you, you shadow the agent, let the agent kind of learn locally and learn how you test things, how you run things in your development environment, and how you basically do all of the checks before you push something to production. And then finally, let the agent run in production, read the logs, take actions for you, and handle things with full autonomy, or however much autonomy that you want. So that's pretty much it. If anyone has any questions, so these are just some additional readings and tools and references that you can check out. And please join our Slack. We will be continuing this conversation there. Feel free to ask us follow-up questions there. There's a lot of educational material in the Bruin Academy, getbruin.com/learn. And you can also, we have about, I believe, 10, 15 minutes left. So I will stick around if anyone wants to basically ask any questions. I'm checking right now for any questions, and I will answer them live right now. So I will just hang around and put myself on mute for now. Okay, so actually, while we are waiting, let's take a look at the poll. So from the respondents, we half of the people are data engineers, as kind of expected. And we have some analytics engineers, some founders, and some data analyst scientists. But I think this is, generally speaking, mostly relevant for data engineers because they're handling the pipelines end to end. And yeah, and I think also on the analytics engineering side, like they are mainly stakeholder facing as well. So I think self-healing pipelines become very important for them to basically prevent things from happening and kind of prevent the business users and the actual data consumers from complaining about the data, as we have, most of us, I think, have experienced. Um, I'm just waiting to see. Yes, so there's one question. Yeah, for anyone that's joining late or anything, don't you worry. Everything will be recorded and posted on LinkedIn and YouTube. And this slide will also be shared with everyone. Check out our Slack for that. We will post the slide in the Slack thread. And we also, so as a follow-up to this event, there's a few things. So firstly, I will definitely share the slides here in the Slack channel. And I will definitely follow up with some actual demos and templates that we have for self-healing pipelines. So we have, for example, a template that helps with building some skills. So some agent skills that handle different types of pipeline issues. And this just kind of like just to give you an idea of if you want to build skills, how do they look like? What kind of information you include in those skills, and it kind of turns into a system prompt or a framework for agents to operate when they're handling pipeline issues. Another thing that we will be following up with is essentially what we did right now in this presentation is more high level. We didn't actually show much code, or we didn't dive into actual like live demos. In the next webinar, which will be about in 1 month from now, we'll be hosting another free webinar, and we're going to dive deeper into the context layer. So we're going to actually look at a pipeline with very minimal context. We're going to ask an agent, hey, like, run this, it fails. We ask it why it failed, blah, blah, blah. And we will see kind of like how it operates. And then we will add some additional context to it and see how it utilizes that specific context to be able to troubleshoot things and diagnose the problem and push the fix as well. Kyle is asking how many people hosting autonomous agents in a Docker image where I need some type of API workflow. That's a great question. I think I can't speak on behalf of most people, but I think setting up your own agent like that is usually what people start off with, based on what I've heard around as well. And to be honest with you, like within bigger organizations, it's very hard to get past the red tape to actually do things like this sometimes. So what people normally do is get started locally, where they just have their agent locally that troubleshoots things for them, does a lot of the initial investigation, which, to be honest with you, most of the times is 80% of the actual effort is investigating things and looking at the logs, looking at the lineage, looking at the code, and also diving deep into even like the Git commits to see, oh, this change made last week is what caused this pipeline failure. So a lot of the initial investigation can be done right now locally, and that's what a lot of people are starting off with. And then when they want to kind of make this something that runs regularly, that's when they look into hosting a server, or deploying it somewhere in a different cloud, or they use kind of like out of the box tools like Bruin Agent or some other platforms agents. All right, so I think there's one more question. Do we need an MCP, or is the skills file enough for this? I think an MCP is more important actually than the skills, because depending on which MCP, so MCPs generally either just give you documentation, so it tells the agent, so it kind of is a skill by itself where it tells the agent what that tool is, what it does, and how to use that tool. And the second part of an MCP normally is actually giving the agent the specific, let's say, API access and stuff to take actions. So for example, the Bruin Cloud MCP can be used for the agent to just go in Bruin Cloud, read the logs, create runs, things like that. So most of the times MCPs should be good enough. Skills, I would say, are normally better for when you want to customize things. For example, you have a specific workflow for when there's a duplicate issue or a data freshness issue, things like that. In those cases, you want to actually basically set up skills where you can define a framework define even to the level of like how should the agent communicate with you, which channels should it actually communicate through. And I think the skills are mostly important for that. We have our co-founder and CEO, Burak. I believe he might have a few words. I'm not sure if he...
Hello, everyone. Arsalan, thanks a lot for
Well,
hosting the event. Appreciate everyone taking the time to join. There have been a couple of interesting questions. First of all, like people are asking if the live stream is going to be uploaded. We're going to upload it and share it through our official channels. I believe we're going to post it on LinkedIn as well. And we're going to be sharing all the artifacts in our Slack community so that the slides and the examples and the link to the recording and stuff. So I dropped the link to the LinkedIn comments at least, so that people can find them. There are a couple of other questions. There's one about needing MCP or skills being enough. I was thinking maybe I could leave that one to you. Kyle has an interesting question about how people are hosting autonomous agents in a Docker image. Are we able to pull up the question here as well?
I believe so, yeah. So I will show the question now. Just to let you know, I did respond about both of these questions, but if you can dive a little bit deeper into this Docker one, I think it would be interesting.
So this is, I think it's like to be quite direct, I think the whole industry has not figured out how to approach this problem in general, like where the agents should live and how should it have access to credentials and sensitive systems and then actions that are being taken under control. There are a couple of keywords. The most obvious one is like you want to run these in some sort of a sandbox where the agent, what the agent can do is strictly limited to a subset of actions and controls that you implement. There are a lot of sandbox providers out there. Inside the sandbox, you want to be able to give the agent a temporary identity so that it can use these identities to get access to live systems. And you would like to pair this with some form of a secret management product. Essentially, all of these different bits they're still like the whole industry is exploring how they work well together. We are soon going to be launching our take on how people should deploy agents on production in a safe and secure way as well. But all in all, it will heavily depend on your environment, industry, your toleration, and the capabilities you have within your team to be able to implement them on production. But I believe a lot of the things Arsalan talked today in this event is applicable regardless of how you run the agents. I think the principles are applicable across all these different tech stacks. Whether you use Bruin or not doesn't matter. And whether you run them in cloud or locally doesn't matter, in a Docker image or through a Slack chat doesn't matter. So all of the principles are directly applicable. So I appreciate everyone joining here, and thanks a lot for hosting this, Arsalan. I see a couple more new questions just popped up.
Yeah.
Let me know if you need any help from my side.
Yeah, for sure. So Mehmet is asking if we have examples for context layer for assets. We can use AI to create our layers for each asset that we currently use by using your docs and examples. We are currently using Claude and Cursor in our processes. They have access to repo and local, so I believe they can define each asset better. So if I understand this correctly, when it comes to Bruin, if you're already using Bruin for your pipelines, of course, you can, a lot of the context already exists there, and there are even specific functions like Bruin AI Enhanced that will go and fill in a lot of that information for you and kind of complete the context for you as much as possible, and then you build on top of that. However, you can also use the CLI, the Bruin CLI, to help you with your existing pipelines that you have. So let's say you have a classic modern data stack with dbt and Airflow, and the context is missing a lot of information. You can basically create a separate context layer with Bruin with just two commands. One is to import basically the schema from your data warehouse, and then another command that will go and basically use an AI to enrich the data. And kind of behind the scenes, actually, what the agent is doing is kind of clever because it's acting like a normal data analyst or data engineer would do when they join a new team, which means that they will basically go query the tables. They will read the metadata of the tables, look at each single column, query it in different ways until it understands kind of what the table is supposed to look like, and then it generates column level descriptions, quality checks, and kind of fills in a lot of that context for you like that. I'm not sure if that answered your question, but I hope it did. We have another question, I believe. From a self-healing pipeline perspective, would Bruin Cloud agents be the solution to Kyle's question above? If so, curious how an agent can interact with other tools in an existing architecture. So yes, the short answer is yes. So the Bruin agent is essentially a managed kind of agent where it spins up in a sandbox environment for you. It will, depending on the access that you gave it, it will have access to your pipelines, your repo, the logs of all the pipeline runs, and it can handle the entire kind of workflow and the loop that we discussed. And in terms of giving it additional access to other things, you can always add additional skills for it to access things outside of the Bruin environment, as well as there are some built-in MCPs that you can basically add to your agent when you configure it so that it has additional access to, for example, Linear or Jira and things like that, or even some documentation things like Notion, Confluence, and that way the agent just out of the box has access to those third-party tools as well.
Just one thing to add there. Part of the question says how an agent can integrate with other tools in an existing architecture to be triggered based on certain events. In the case of Bruin Cloud, it contains a lot of different APIs that allows you to hook into agent sessions, trigger new executions via the API or via the bunch of different integration points we support, which means anything that can speak to an HTTP API can integrate with Bruin Cloud's agents.
All right, perfect. I believe we're at time. So if there's no other questions, I thank you again, everyone, for joining us, and feel free to reach out to us in Slack or anywhere else, and we'd be happy to answer your questions. Just another reminder, we are hosting the next webinar in almost 1 month from now. And as I mentioned, we're going to deep dive into the context layer, and it will be kind of a webinar / workshop. So we're going to be more hands-on in that one and actually kind of do some coding together as well. So I hope everyone enjoyed, and have a good evening or morning wherever you are. Thank you.